has an abundance of moving water. Sun sparkling on the Willamette River as it flows through the city reminds Portlanders of the surrounding natural environment. The river provides jobs, fish and wildlife habitat, and recreation. To the north, the Columbia Slough, a Willamette tributary, contains one of the country's largest urban wetlands. The slough is a popular place for paddling and home to native wildlife and fish, including coho and Chinook salmon. Despite their value to the city, protecting the river and slough wasn't always a priority. Portland incorporated in 1851, but didn't build a sewage treatment plant for another 100 years. After the city's first treatment plant opened in 1952, water quality improved. But the sewer system in most Portland neighborhoods still combined sewage and stormwater in the same pipes, which is how early city engineers designed it. During dry weather, combined sewers carry all the city's wastewater to the treatment plant. But when it rains, stormwater washes over streets, parking lots, and buildings and flows into the combined sewer system. During heavy rains, combined sewers can fill to capacity and overflow. Most of these combined sewer overflows, called CSOs, contain about 80% stormwater and 20% sanitary sewage. The bacteria in sanitary sewage can threaten public health and the environment. In 1991, the City of Portland and the Oregon Department of Environmental Quality entered into a formal agreement that required the city to significantly reduce CSOs by 2011. When the 20-year CSO control program began, an average of 6 billion gallons of combined stormwater and sewage overflowed to the Willamette River and Columbia Slough every year. Portland's solution to the CSO problem was to remove as much stormwater as possible from combined sewers, then construct large tunnels to capture, store, and convey most of the remaining flow to the sewage treatment plant.
In order to remove stormwater from the combined sewers, the Bureau of Environmental Services began with a series of Cornerstone Projects.
We installed stormwater sumps and sedimentation manholes to collect relatively clean water and let it soak into the ground. In some neighborhoods, we installed pipes to carry stormwater runoff to natural treatment ponds. We separated several streams that were once diverted into the combined sewer and piped them directly to the Willamette River. Finally, we created a downspout disconnection program to disconnect roof drains from the combined sewers. Thanks to incentives given to property owners, we disconnected over 56,000 downspouts, which removed nearly 1.2 billion gallons of stormwater from the combined sewers each year and saved an estimated $300 million in construction costs.
The Cornerstone Projects were cost-effective, relatively easy, green solutions. The more complicated CSO tunnel construction was the next challenge. Because these early projects reduced stormwater flow to the combined sewer system by about 1/3, engineers could reduce construction costs by designing smaller tunnels to collect and convey combined sewage. Portland's CSO control approach resulted from 3 years of work with technical experts, interest groups, and the public. The 1994 CSO Facilities Plan was a mix of stormwater inflow control projects, CSO tunnels, and treatment plant improvements.
We also added an influent pump station for the Columbia Slough Big Pipe. We built new primary clarifiers, added a second outfall pipe, and built a facility to remove chlorine from treated water before discharge to the Columbia River.
The first large CSO construction project was the 3.5-mile-long Columbia Slough Big Pipe, which ranges from 6 to 12 feet in diameter. The project included expanding treatment plant capacity to handle additional flows. The Columbia Slough projects, completed in 2000, reduced CSOs by more than 99% to the slow-moving, environmentally sensitive Columbia Slough. The next project, the Westside Big Pipe, was more complicated. 2 tunnel boring machines, one moving north and one moving south, worked 120 feet below ground to construct the 14-foot diameter, 3.5-mile-long tunnel along the Willamette River's west bank and under the river to Swan Island on the east side. The boring machine, working under Portland's waterfront park, tunneled past several Willamette River bridge footings. Work crews injected concrete into the ground to safeguard against surface settlement as the tunnel boring machine passed by. The machines that constructed the Westside Big Pipe used 16-foot diameter cutter heads. As the rotating cutter heads chewed through earth and rocks, the machine mixed displaced soil with bentonite clay and pumped it to the surface. A separation plant removed the bentonite for reuse, and barges haul the soil upriver to help restore the Ross Island Lagoon. As the machines advanced, hydraulic arms behind the cutter head installed precast steel-reinforced concrete segments to form tunnel rings. Jacks pushed against the assembled rings to propel the machine forward. The Westside Big Pipe is large enough for a Greyhound bus to drive through with room to spare. The city excavated 5 large tunnel shafts as part of the Westside project. The tunnel boring machines, workers, and supplies entered the main mining shaft at Northwest Nikolai Street. The shafts connect combined sewer overflows to the tunnel and provide tunnel maintenance access. The Westside Big Pipe connects to the Swan Island pump station, which was constructed below ground inside a 123-foot diameter shaft. At 160 feet deep, the shaft is large enough to hold a 15-story office building. Because the shaft bottom is well below the water table, pumps operated round the clock during construction to lower the groundwater table within the excavation. During wet weather, the Swan Island pump station can pump 100 million gallons of combined sewage per day from the Westside Big Pipe to the treatment plant. The Eastside Big Pipe was Portland's last major CSO construction project. At 22 feet in diameter and almost 6 miles long, it was also the largest public works construction project in the city's history. An adult giraffe could stand up straight inside the Eastside Big Pipe. The construction method was similar to the West Side. The city's contractor used a larger, single machine to construct the Eastside Tunnel, and there were some new challenges on the east side of the river. Engineers had to alter the original tunnel alignment to avoid the footings of large bridges and ramps at a major freeway interchange. Despite those obstacles, a sophisticated laser guidance system led the tunnel boring machine to within 1 inch of its target. With tunnel construction complete, the city finished work on several smaller CSO projects. They included the Portsmouth Force Main, the Balch Consolidation Conduit, and the Selwood Wet Weather Pump Station. Completing those projects brought major CSO construction to an end. Throughout the $1.4 billion program, the city had no federal or state funding assistance.
I'm very pleased to say that it's a big investment, but it's been done on time and at this point under budget too. But nevertheless, it's been a significant cost to ratepayers, but I think a lot of ratepayers agree with the ultimate goal, and that is less combined sewer overflows into the Willamette River and the Columbia Slough. For the first time in 150 years, we have no combined sewer overflows anymore in the Columbia Slough. And when we're done in the Willamette, we will go from 50 overflows a year in the winter to less than 4. And then in the summertime, we will have 1 overflow every 3rd year.
It's beautiful and it's a wonderful part of Portland.
It's calm, it's peaceful, and clean.
Sort of makes you feel good just having a big section of nature right there in the city.
Although Portland has completed its requirement to control CSOs by 2011, the combined sewer system remains, and the city's work to keep stormwater out of combined sewers is as important as ever.
We view stormwater as a resource and not a waste. Instead of sending clean rainwater to the sewer system, we're investing in green projects that mimic nature.
Green Street facilities, for example, are small rain gardens planted along streets. They collect and slow street runoff and let water soak into the ground. Soil and plants filter pollutants, and the runoff replenishes groundwater supplies. Eco-roofs are another example of green infrastructure. These are vegetated roof systems that absorb rain to reduce runoff. They also cool the air, insulate buildings, and create habitat for birds and beneficial insects. Portland also works with dozens of partners, planting thousands of street and yard trees to expand the urban forest. Trees capture rain, reduce erosion, clean the air, and beautify our neighborhoods.
Portland receives 37 inches of rainfall a year, and we can't simply rely on our big pipe system to handle all that. We have to search for alternatives to putting clean water into our big pipe system. And I think that's not only keeps up with our growing, thriving community, but also speaks to something that's very much cherished here by Portlanders, and that is sustainable solutions that are creative in keeping rainwater out of our system in the first place.
Portland is here because the Willamette River is here. The river helps make Portland a great city. Our predecessors lost sight of that. They used the Willamette as an open sewer and turned their backs on it. We inherited a river abused by past generations. But now we're learning to become active stewards of our waterways. Today, Portland and its citizens work together for a clean, healthy, and vibrant river for us and for generations to come.